Yeah, good morning everyone. I hope am I audible? Audible and my screen is visible, right? Okay, let's get into our second session. Yesterday we have dealt with linear measurements, right? Sir, what is survey? Objectives of survey, principles of survey, linear measurements, and what are the angular measurements, basics of surveying, classification of survey, all these things we have discussed, right? Um, Today, we previously discussed about chain surveying. What are the things in linear measurements? Chain surveying and tape surveying, and we just dealt with chain. What are the equipments used in chain surveying, and how do we range? Right? What is ranging? How do we do ranging? Ranging is required when the length of the line is measured greater than chain length. If my length measured is greater than chain length measured is greater than chain length, then ranging is required. There are two types of ranging. Okay. So there are two methods of ranging, direct ranging and indirect or reciprocal ranging. What is direct ranging? When my two station points of survey are visible, intervisible, then we go for direct ranging. Okay. So how can we do direct ranging? By eye judgment and by using line ranger. So with this we can do our direct ranging. Okay. So this is easy and convenient method. What if we have obstacles and my both stations are not visible? If my both stations are not visible, then we go for indirect ranging or reciprocal ranging where two station points are not visible. Okay. For suppose this is the case. This is a hill. Okay, few 1.2, 3 and 4. So these are intervisible. Not these are not intervisible, right? So then what we will do is we will do ranging by help of random line method. Random line method. Okay, it is used to establish the intermediate station by reciprocate ranging. Random line method is used to establish the intermediate station by reciprocal ranging. So these are two types of ranging, direct ranging and indirect ranging. Okay. Next, as we have discussed in the previous class, there will be errors while we are doing survey, right? The errors may be instrumental errors, personal errors, accidental errors. We have discussed in the last class. So now, what are the errors due to incorrect chain? Okay, when my chain is too long, the measured distance is less. When my chain is too short, the measured distance is more. You know it, right? If my chain is too long, my measured distance is less, then the error is negative. Then the error is negative, correction is positive. Then that means if I get minus, my error will be in minus 1, minus 2. Then I need the corrected value is I need to add it to it, add to the measured length. Okay. If my chain is too short, then error is positive, correction is negative. Got it? Now, okay, let's deal with the corrected length, area, and volumes. Okay. How do we do with the corrected length? What is the formula for corrected length? So corrected length. let's suppose L is equal to L dash into L by capital L by small l. So what is this terminology? What is L dash? L dash is nothing but measured length. Capital L dash, incorrect length of chain. Incorrect length of chain. L, true or designated length of chain. Okay. So what is L dash? How do we do the incorrect length of chain? L dash is nothing but L plus delta L. True length plus what is the error? Delta L. If it is the change in length is delta L. L dash is equal to L plus delta L. So if I do L dash by L, then L plus delta L by L, that is equal to 1 plus delta L by L. Let's take this delta L by L as, or 1 plus delta L by L as E. It's nothing but error. Okay. Then my, what goes with L? L is equal to L dash of 1 plus E. Got this? So this is your corrected length. Corrected length L is equal to L dash of 1 plus E. What is L dash? Measured length. E is 1 plus, E is error. Okay. That error is calculated by delta L by L, change in length through the two length. So next is corrected area. Corrected area. Corrected area A. It is nothing but A dash into L dash by L whole square. So what is A dash? Measured area. L dash is incorrect length of the chain. L is the true length of the chain. Got it? So I can write A is equal to, corrected area A is equal to A dash into 1 plus 2E, right? Next, corrected volume. So corrected volume V is equal to V dash into L dash by L whole cube. So we can write this as V is equal to V dash into 1 plus 3E. Got it? So now give me the values for corrected length. Here we will write a summary. L is equal to L dash into 1 plus E. And corrected area A is equal to A dash into 1 plus 2E. Corrected volume V is equal to V dash into 1 plus 3E. So as we all know, E is nothing but the error. Okay. So this E is the cumulative error. So there are two cases. Case 1, if my error is 0 at the beginning of survey, if I got 0 error, and at the end I got E, error E at the end, then I have to take E average. That is equal to 0 plus E by 2. E by 2. Okay. When there is 0 error at the beginning and we have error E at the end, then we need to consider average error in the calculation. Okay. In case 2, if we have error E at begin, if we have error E at beginning, E1 at beginning, and E2 at end, then my E average is, yes, E1 plus E2 by 2. Okay. This E must be the average. Here E is nothing but E average. Got it? These are the corrections. Corrections for incorrect chain. Next, chaining on uneven and sloping ground. Okay, so if, as you all know, our earth is not a flat surface. We have undulated surface, right? So because of undulations, there will be error in the chaining because the chain won't be flat. There will be some undulations, sagging, pulling, and like that we will get some errors, right? So if what do we do if we chain on uneven or sloping ground? For example, a hill like this, if we have to do if we want to calculate the length of this, sir, yeah, direct this distance d, then what do? We will go for this direct method. What do? We will do the offsets like this. We will do the offsets like this, and this d can be calculated using this. It is summation of L1 plus L2 plus L3 and so on, 1 to n. Okay. If I want, and generally what do we do is measuring down the hill is easier than going up the hill. If I want to measure this distance, I will just go for down, not, I will just take this. This is easier than this. Okay. So this is direct method where we can project projections and we can calculate the length. But sometimes there won't. This is not feasible. Okay, because of heavy undulations or heavy slopes. Then what do? We need to consider the slope also in that case for the correction of for the calculation of length. Okay. So here, the second case, this is indirect method, and clinometer is used to measure the angle. What do? Is we will consider one point and we will draw one horizontal point. We will calculate the angle here. Okay. So how D is calculated? D is equal to L1 cos theta. Excuse me. D is equal to L1 cos theta 1 plus L2 cos theta 2, right? Two different angles. So like that, D is equal to summation of 1 to n L cos theta. Okay. And next, so if this is the case, I know the h, d, and I know the h, and I need to calculate this L, and I need to get the d. So which equipment is used? Ebne level is used to measure the level difference between A and B. Okay. So it can be calculated using the formula Pythagoras theorem. D is equal to root of L square minus H square. Using this we can calculate, right? Next, hypotenuse allowance. Hypotenuse allowance. What is that? It is the correction to be applied in the field at every chain length and every point when the slope changes. Okay, when the slope change, where the slope changes. This facilitates in locating and surveying the intermediate points. As you can see, I can chain till here only. So this A dash is my error. So wherever the slope is changed, we need to there may not be always the right angular things, right? So my chain can be go till here because of this curve. Then A dash is my hypotenuse allowance. So how do we calculate hypotenuse allowance? A dash is equal to, from this triangle you can see, A dash is equal to total AB minus A dash B. Okay. So hypotenuse allowance A dash is equal to AB minus B dash A. Then how do we calculate theta? Cos theta. Cos theta is equal to BC by AB. Okay. So this BC, we take one chain which has 100 links. So that BC is nothing but a chain having 100 links. Okay, generally 20, as you know, 20 meters chain we discussed in the previous class. 20 metric chains are of 20 meters and 30 meters. For 20 meters chain, we have 100 links, right? So I'm considering this BC as 100 links divided by AB. So AB is equal to 100 secant links. It is 1 by cos theta secant, right? So AA dash is equal to 100 secant theta minus 100 links. Got it? So AA dash is the correction for one chain. That means if I am considering 20 meters chain, then my hypotenuse elements is this one, 50 theta square, or 50 theta, it's not, yeah, theta square if theta is in radians. If I want in degrees, then I need to divide it by 1000, 0.015 theta square. Okay. And when the slope is given as 1 by n, not like theta. Okay. So this theta is generally considered as tan theta, and it is considered as 1 by n, slope, opposite side by adjacent side. Okay. 1 by n. So AA dash is equal to 50 by n square links. So 50 by n square into the measured length will give you the hypotenuse allowance. When we measure with 20 meters metric chain. Okay. So if we go with 30 meters chain, then how many links will be there? 150 links, right? Then my hypotenuse allowance will be 150 into secant theta minus 1. Okay. 75 theta square links. So this is one of the most asked questions. So let's see one example. What is hypotenuse allowance per chain of 20 meters length if the slope is 12 meters, angle of slope is 12 degrees, sorry, and the slope is 1 in 5. What is the hypotenuse allowance per chain of 20 meters length? So we are given length of the chain equal to 20 meters, and it is given this angle of slope, that means theta is equal to 12 degrees. They are asking us to calculate hypotenuse allowance. As we know, so it is how many the hypotenuse allowance is equal to the measured length into secant theta minus 1, right? So it is given chain of 20 meters length. So 20 into secant theta minus 1. So substitute the theta 12 degrees, then we got the answer as 0.45 meters. Okay. And in second case, the slope is given in 1 in 5. It's like 1 by n. As we discussed, the theta we can take it as tan theta. Tan theta is equal to 1 by 5. So we from that theta is equal to tan inverse of 1 by 5. Then the value is 11 degrees 31 minutes. So what is the hypotenuse allowance in this case? So how much length we measured? 20. So 20 into secant theta minus 1, right? 20 into secant theta and the 11 degrees 31 seconds. So 1 by cos 11 degrees 31 minus 1. So here comes your value 0.396 meters. So what is the thing we need to do? The measured length plus this hypotenuse allowance we need to check if you are going with the total survey. So this is the error, hypotenuse and okay. Till then we go we have completed the errors due to chain. Okay. So in linear measurement, uh, linear measurements can be done with help of chain, tape, right? So we dealt with chain. Now we consider tape. What are the corrections? What are the tape corrections? In previous class we discussed. So there will be some errors while we are doing direct measurements using chains and tapes. So till now we have dealt with chains. So what are the tape corrections generally? Okay. So the corrections are correction for standardization. Correction for standardization. correction for slope, correction for misalignment, correction for temperature, correction for pull, correction for sag, correction for normal tension, correction for mean sea level. We'll consider one datum, right? Mean sea level. And correction for offsets. What do we do? We'll go with the offsets now. Then that limiting length of offsets are considered. So we'll go with the first correction. Correction for standardization. So it is nothing but CA is equal to L into C by L. So this L is the measured length of the line. C is the correction of tape length. L is the designated length of the tape. Okay. So if CA is positive, then the chain or tape is too long. If CA is negative, then the chain or tape is too short. You got it right. If my error is positive and my error is negative, what is the chain length? We have discussed it earlier. So correction for standardization, CA is equal to L into C by L. Next, correction for slope. So that is equal to L minus root of L square minus H square. Or if it is given in thetas, if you know the slope, then CSL is equal to L minus L cos theta. Okay. So if it is given in height, then CSL, correction for slope, is equal to H square by 2L. If I get that in thetas, then CSL is equal to L into 1 minus cos theta. Next, correction for misalignment. So correction for misalignment, you can see if they are not in the same line. If my 2 points are not in the same line, if it is like this, okay, then it has two different slopes, right? Here theta 1 and theta 2, you can see. So if I join it to the point, this line is not straight. This is not giving 90 degrees. Here we will get theta 1 and theta 2, two different angles. So that correction for misalignment, CMA is equal to d square by 2 into L1 plus d square by 2 into L2. Got it? And it can also, this if my d is given, and if thetas are there, then I can do it like CMA is equal to L1 into 1 minus cos theta plus L2 into 1 minus cos theta 2. CMA, you need to remember, CMA is always negative. Correction for misalignment is always negative. That is a cumulative error. Sorry, compensate negative error. Okay. Correction for misalignment is always negative. You need to remember it. Next, correction for temperature, CT, is equal to L into alpha into Tm minus T naught. What is this L? L is the measured length. Alpha is the coefficient of linear expansion. Okay. And Tm is the temperature during measurement. T naught is the standard temperature. When is my CT positive? If Tm is greater than T naught, if my Tm is greater than C naught, then my CT is positive. If my Tm is less than 3 naught, then my CT is negative. We know it, right? So that is the temperature correction. Next, correction for pull. So correction for pull, CP is equal to P minus P naught by AE into L. Okay, so that CP is this P is the pull during measurement. P naught is nothing but the standard pull. A is the area of cross section of the tape. E is the modulus of elasticity of tape. So what is modulus of elasticity of tape? Generally, we consider them, they are made of steel. If it is not mentioned in the problem, then you need to take E as 2 into 10 power 5. Okay, 2 into 10 power 5 megapascals you need to take it as. L is the measured length. So this is the correction for pull. So if when is my Cp positive? If my P is greater than P naught, then Cp is positive. If my P is less than P naught, then Cp is negative, right? We know it. So this is the correction for pull. Next, correction for sag. So you know that there will be some sagging whenever whenever 2 points in this 2 points, if this is not held properly, there will be some sagging. So because of that sagging, there will be some error in the measurement. So what is that error and how do we do the correction? So let's consider this as L and this total length is equal to N into L. Okay. So if both supports are at the same level, then my C sag is equal to WL whole square into L divided by 24 P square. What is this WL? Yes, this WL is nothing but the self weight of the tape. Okay, it is nothing but self weight. Self weight is W, and it is a uniformly distributed load. Hence, it is an UDL. We will consider that as W into L. Okay, the whole load as W into L. So WL whole square into L divided by 24 P square. This is your correction for sag. If my chain is of length L, or my tape, sorry, it's not chain, tape is of length L, and we have used for n number of ways, n number of base, then what do? We will multiply it with n. Oh, sorry. If n number of base, then we will multiply it with n. Okay. After simplification, this L and we are doing this. This small L is nothing but capital L by N, right? So W square into L by N whole square into L divided by 24 P square. On solving, we get it as WL whole square into L divided by 24 N square P square. After simplification, we get C sag. We get C corrected length due to sagging is nothing but W square L divided by 24 N square P square. Okay. So I already dealt what is W, self weight of the tape, and it is a uniform distributed load. We have considered it as W into L. Okay. The condition for sag is the correction for sag is always negative. You need to remember this. The correction for slag is always negative. So this is the case if my ends are at the same level, right? If my ends are at different level, then what is the case? C sag is equal to C dash sag. If my ends are at different level, there it is like that, right? Here it is like this. My ends are at two different levels. Then C sag is equal to C sag into cos square theta. That level 1 into that. What is that C sag there? W square L by W square L by 24 N square P square into cos square theta, right? So what is the correction for normal tension? So what is the correction for normal tension? As you know, the chain is when we hold it when we hold the chain between 2 points, tension will be developed. What this tension outside force will be developed in the chain. Okay. So what will be the correction for normal tension? So Pn is equal to 0.204 W into root AE divided by root of Pn minus P naught. So what is this Pn? Pn is nothing but the normal tension. P naught is nothing but the standard pull. The W is the total weight of the tape. A is the cross-sectional area of the tape. E is Young's modulus of the tape. Okay. So Pn is equal to 0.204 W into root A divided by root of Pn minus P naught. Okay. This is the correction due to normal tension. Next, correction due to mean sea level. Correction due to mean sea level. As we know, we'll consider mean sea level as our datum. So if there will be correction. MSL is equal to L into H by R. L is the length of tape, H is the height of the object above the mean sea level, R is the radius of curvature of Earth. In the first class, I told you, if R, the radius of curvature of Earth is not given, then we need to take 6370 kilometers. Okay. CSL is a positive if the object lies above the mean sea level. So if this is my mean sea level, if my object lies above, then my correction CMSL is positive. If my object lies below the mean sea level, then my correction is negative. Okay. So next one is limiting length of offsets. Generally, what do? We will project one offsets like that from the points, and we will calculate, right, while ranging. Okay. So there will be some limiting length of the offsets. That formula is given as limiting length of offset L is equal to S into R by root of 40 root divided by 40 root 2. You need to remember this. Okay. If limiting length of an offset by considering both linear and angular displacement, this is the formula. L is equal to S into R divided by 40 root 2. So now let's deal with few previous gate problems. In this, we can expect a problem, I mean a question from this topic, errors and their adjustments. Okay. So either we can get in first session, or we'll get the problem here, right? Problem from this session. Oh, so let's take some previous grade problems. Let's solve for an example. A steel tape of 20 meters long, standardized at 550 feet, was used for measuring a baseline. The temperature during the measurement was 300 Fahrenheit. Okay. If the coefficient of linear expansion of steel, they have given alpha as 6 into 10 power minus 6 divided by Fahrenheit. Okay. So generally we'll measure in divided by Celsius scale, right? Divided by Celsius. Here they have given in Fahrenheit, no issue. So correction for temperature per tape length. They are asking correction for temperature per tape length. So what is the correction for temperature first? Ct is the correction for temperature, right? Ct is equal to L alpha Tm minus T naught. What is L? Measured length. Alpha, coefficient of linear expansion. Tm, temperature at the measured time. T naught at the ideal time, right? So what is this alpha? Sorry, first length. Length is 20, right? 20 meters they have given. Alpha is 6 into 10 power minus 6. Next, temperature at the time of measurement. So temperature at the time of measurement, he has given 300 minus 550. So what is your value? Minus, it will be minus, right? Minus 0.003 meters. So D is your option. So this is your temperature correction for this problem, right? Next, let's go with another problem. A chain, a 20 meters chain is used for survey was found to be 20.10 meters at the beginning and 20.30 meters at the end of work. The area of the plate drawn to a scale of 10 centimeters is to 8 meters was measured with a planimeter was found to be 32.56 square meter. The true area of the field in square meters. Okay. So it is given initially the chain length is found to be 20.10 and at the end 20.30 and the area measured is 32.56 with a scale of 10 centimeters to 8 meters. So they are asking the true area of the field in square meters. Okay, got the point? So now we need to calculate the measured length first. L dash, L dash, how do we do? So it is 20.10 plus 20.30 divided by 2. I have given you average error we need to take. So 20.2 meters. So this is the 20 point average, error average. Next, how do we calculate area? Corrected area is equal to A dash into L dash by L whole square. You know it, right? So what is the area measured? Measured area is 32.56 into 20.2 error. 20.2 divided by original area is original length is 20, right? 20.2 by 20 whole square. What is this value? 33.21 centimeter square. So this is your corrected area, right? So this is your corrected area. Corrected area is equal to 33.21 centimeter square. They have told like the scale is 10 centimeters is equal to 8 meters, right? So then what is 1 centimeter? 0.8 meters. Now they are asking the corrected area in square meters. So I need to convert this to square meters. So 33.21 centimeter square is equal to 33.21 into 1 centimeter is 0.8 meters, na? 0.8 whole square. So it is 21.256 meters square. So this is your correct area in meter square. What they have asked, the true area of field in square meters. So what you got? Answer as 21.256. So first one is your answer. 21.256. I think you got it. How do we measure the L dash? It is like cumulative error, right? We need to take the average of the error at the end and the at the beginning, at the end average. After that, I have calculated corrected area using the formula, and with the scale we have changed, converted the true area into meters, square meters. So here ends your first part. That means linear measurement. So linear measurement part here ends. Now let's go to the angular measurements. Okay. So in linear measurements, what are the equipments used for the linear measurement? What are the errors occurred while we are measuring? And how do we correct it? We discussed all these things here. And we discussed two examples also. So how do we go with the angular measurements? So with we use compass. Previously we have dealt in the yesterday's class with help of compass, with help of theodolite. We will with help of total station we can measure the angle, right? So first one, with help of compass, how do we measure the angle? So, and how do we the direction? With that measurement we can go with the we can get the direction of measurement, right? So direction of that line can also be measured. So let's go into some terminologies for the magnetic compass survey and all. So there are different types of meridians. There are true meridian, magnetic meridian, grid meridian, arbitrary meridian. What is true meridian? True meridian is nothing but if my point, if it is a point, a great circle passing to the geographical north and geographical south of point passing through the geographical north pole and south pole of Earth's surface. Line joining geographical. That means Earth north and south. Geographical north and south pole of Earth surface of Earth is called true meridian. Okay. So what is magnetic meridian? It is the direction showing it shows the magnetic north when suspended freely. It shows magnetic north when suspended freely. Okay. Magnetic meridian is the direction shown by magnetic north when it is suspended freely. What is grid meridian? Grid meridian. It is a reference line established by state governments. It's a reference line established by state government in the middle of the state for various projects of various departments. It's like a reference line. Okay. So it is a reference line established by state governments in the middle of the state for their projects in various departments. Next is arbitrary meridian. What is arbitrary meridian? It is a local reference point, generally local reference point. Local reference line is called arbitrary, and this is not temporary. We'll just consider it for that place. Local reference point taken for measurement. is arbitrary meridian. Okay. So these are the terminologies you need to know. What is true meridian, magnetic meridian, grid meridian, and arbitrary meridian. Okay. Next point is bearing of line. This is very important. Bearing of line. So what is bearing of line? It is the horizontal angle between the meridian and a survey line. Okay. It is the horizontal angle between the meridian and a survey line. That is called bearing of line. Okay. And what is true bearing? True bearing. True bearing is nothing but the horizontal angle between true meridian and the survey line. Horizontal angle between true meridian and survey line. That is called true bearing. It is also known as azimuth. You need to remember it. Generally, if they want to trick you, they will give the azimuth of a line. That means the true bearing of the line. That means the angle made with the true meridian. Okay. And it doesn't changes with time. It doesn't changes with time. Okay. So it is a constant everywhere. My true bearing is constant everywhere in the universe. It doesn't change with time. It doesn't change with location. Okay. Next, magnetic bearing. What is magnetic bearing? Horizontal angle with which line makes with the magnetic north. What is magnetic north? When the magnet is suspended freely, it has a tendency to to suspend in its north direction. It shows its true north, right? When it is suspended freely. So, what the horizontal angle which the line makes with the magnetic north is nothing but magnetic bearing. It changes with time. So it is not constant. Okay. It changes with time. Because here at our place, the magnetic flux is different. In another country, the magnetic flux is different and the direction is different, time is different. Then it will be suspended in different direction. Okay. So magnetic bearing is not constant everywhere. It changes with time, and it is measured with help of magnetic compass. Magnetic bearing is measured with help of magnetic compass. Okay. Next, very important one, magnetic declination. Magnetic declination. What is magnetic declination? The horizontal angle between the true meridian and magnetic meridian at a particular place is called magnetic declination or dip. Okay. Horizontal angle between the true meridian and magnetic meridian of particular place is called magnetic declination. So let's consider north, east, west, south. So this is my survey line A. Okay. So the angle, this is your true north. Then the angle passing through this is called true meridian, right? And this is the meridian passing through the magnetic north. Okay, magnetic meridian. So what is my true bearing? This one is my true bearing, right? And this one is my magnetic bearing. This is nothing but theta dip declination. Dip theta west. This is western declination. Western declination. So how do we calculate MB? Magnetic, you can see that magnetic bearing is equal to true bearing plus western declination, right? So true bearing in this case is equal to magnetic bearing minus theta W. Okay, this is your declination when your declination is towards western declination. Now we consider eastern declination. We'll draw one line, north, east, west, and south. So this is your north. If your true north is here, true north is here. This is your TB, true bearing, and here is your magnetic bearing. Okay. So, oh sorry, this is my so this is my survey line. Okay. What is your true bearing? The angle between the true north and your survey line, right? Angle between the true north and your survey line. This is your true bearing, TB. So what is your magnetic bearing? Angle between the magnetic meridian and the survey line, right? Angle between the magnetic meridian and the survey line, MB. So what is this? This is your difference, dip, declination, magnetic declination. So this is eastern declination. Here my magnetic bearing is equal to true bearing minus theta e. So what is my true bearing? Magnetic bearing plus theta e. Okay, got it? So this is your magnetic declination in these cases. So they will ask you, they will give sometimes the true bearing and magnetic bearing, they will ask you to calculate theta, magnetic declination. And sometimes they will give magnetic declination and any one of true bearing or magnetic bearing, then they will ask you to calculate. So there will be problems like this. Okay, fine. Next, what are the systems of bearings? Let me rub this once. Next one is systems of bearings. One, whole circle bearing. This is also called as WCB system or Azimuthal system. The second one is quadrantal bearing or reduced bearing system. Quadrantal bearing or reduced bearing system. Okay. So these are the two systems of bearings: whole circle bearing system. It's also called as WCB or azimuthal system, quadrantal bearing or reduced bearing system. Okay. So the bearing of line will be measured with respect to north or south, whichever is nearer. Line will be measured with respect to north or south, whichever is nearer. Whichever is nearer, we will consider that as the bearing of the line. Okay, the bearing of line will be measured with respect to north and south, whichever is nearer. If it is near to the north, we will go with the bearing from with respect to north. If it is nearer to the south, then we consider the bearing with respect to south. So you can see the whole circle bearing here, and the quadrantal bearing. How do we mention in whole circle bearing? And in the reduced bearing, we will mention like into what are the two quadrants. In two quadrants, it is present north, theta, west. If it is here, you can see conversion of WCB into QB. So if it is like this, then we go for north, theta, east. So if it is like that, so it is nearer to south, right? South 180 minus theta east. In this case, it is mentioned like south theta minus 180 west. So you can write it like north, east, west, south. So south 180 theta minus 180 west. So here north and it is in the north and west, right? So north 360 minus theta west. This is conversion of WCB, whole circle bearing, into quadrantal bearing. We'll just consider the poles, two poles and the angle between them in conversion. Second, conversion of QB into whole circle bearing. QB is reduced bearing, conversion of reduced bearing into whole circle bearing. So if this is the case, what do? We'll just give the theta. If my survey line is present between south and west, then it is like 180 minus theta. In this case, 180 plus theta, 360 minus theta. So these are the conversions you need to remember, you need to memorize, you need to practice this one, conversion of whole circle bearing into reduced bearing, and vice versa. So what is forebearing? Next part is forebearing. Bearing of a line measured in the direction of survey, then it is called forebearing. If the bearing of line measured opposite to the direction of survey, opposite to the progression of survey, then it is called back bearing. Got it? So if this is my, yeah, here I can see. If this is my thing, this is my forebearing. It is measured in the direction of survey. So this is my back bearing. It is measured opposite to the direction of survey. So let's see one example. They're asking the back bearing of line BA, line AB, sorry, back bearing of line AB. So back bearing of line AB is nothing but bearing of line BA, right? So we can see it in the progression. What is the angle? Theta. So bearing of line BA is theta plus 180. Bearing of the line BA is theta plus 180. So this is your theta, and this is horizontal angle 180 theta. So theta plus 180. What is this theta? Theta is nothing but your forebearing. That is the angle measured in the direction of survey, forebearing. So from this you understand like back bearing is equal to forebearing plus or minus 180 degrees. Okay. So if we use positive if my back forebearing is less than 180 degrees, negative if my forebearing is greater than 180 degrees. Got it? So my back bearing is equal to forebearing plus or minus 180. So there are two types of compasses generally we considered in the compass survey, that is prismatic compass and the surveyor's compass. So what is the difference between the main difference between prismatic compass and surveyor's compass? Prismatic compass is it has a broad type of needle like this. Surveyor's compass, it has edge bar type needle will be like this. Okay, the graduated scale is attached to the, okay, let's write like this: prismatic and surveyor's compass. So here graduated chord ring is attached to the needle, and the graduated chord ring is attached to the compass box. To needle, either to compass box. The gradations generally it follows WCB system, it follows QB system. These are the important points. There are a lot more differences, but you need to remember these 2 points. That's it enough. Okay, so these are the different types of compasses generally we use. So what are the temporary adjustments? What are the temporary adjustments in this type of survey? Is centering, leveling, and focusing the prism. So these are the temporary adjustments we do in the compass survey to calculate the angle. Okay. So next, calculation of interior angles from given bearings. How do we calculate interior angles from given bearings? Calculation of interior angle from given bearings. So this is your true north. For this place it is your north. A, B, C and D. Okay, so I want to calculate B, angle B. So this is what is from true north to your survey line. This is your angle, right? So from true north to your survey line. So this is your true bearing, and this is your angle, internal angle. This is angle B, and this is the back bearing. This is the back bearing of B, right? So B is equal to, how do we calculate angle B? Angle B is equal to 360 degrees minus, the whole angle is 360, right? So 360 minus back bearing of AB. plus back bearing of AB plus forebearing of BC plus forebearing of BC. Right? Got it? So this is the whole angle. This is the back bearing. This is the back bearing of AB plus forebearing of BC. We calculate the angle B. With that we can calculate angle B. Next, angle C. Angle C. C is equal to. So now tell me what is C? This is your back bearing, right? This is forebearing and this is back bearing. So how do we calculate C? C, angle C can be measured as forebearing of CD minus back bearing of BC, right? So forebearing of CD minus back bearing of BC. And from this we can say like calculation. This is like calculation of interior angle from given bearings. So how do we calculate bearings from given interior angles? Calculation of bearings from given interior angles. If interior angles are given, then how do we go with the bearings? A, B, C, and D. If I know the interior angles, all these interior angles, how to calculate bearings? Forebearing of BC is equal to forebearing of BC is equal to back bearing of AB minus angle B. Look at this. So forebearing of BC is equal to back bearing of AB minus angle B. Next, 360 degrees minus forebearing of DA plus back bearing of CD. What is this angle? 360 degrees minus forebearing of DA plus back bearing of CD is nothing but angle D, right? Next, forebearing of DA is equal to 360 degrees minus angle D plus back bearing of CD, right? You can check it. Forebearing of DA, that is angle with this thing, DA is equal to 360 minus angle D, 360 minus angle D plus back bearing of CD, right? So this is how we calculate the bearings from the given interior angles. Next, okay, now let's take a traverse like this, rectangular traverse. Rectangular traverse. Then A, B, C, D. Now tell me, back bearing of AB is equal to, sorry, bearing of AB is equal to bearing of DC. bearing of AD is equal to bearing of BC. Got it? So till now we have seen how do we measure angles using compass, and what are the adjustments we make, and what are the different types of compasses used, what is the bearings, how do we calculate angles, different systems, different coordinate system, how do we calculate angles if bearings are given, and how do we calculate um, how do we calculate internal angles if bearings are given, and how do we calculate bearings if these things are given, internal angles are given, right? So we have dealt till now the angular measurement. And declinations we have seen, right? Magnetic declination, eastern declination and western declination. And these declinations are also some like diurnal variations, annual variations. As I told you, there won't be constant things, right? So there are diurnal, annual, secular variation, and irregular variation. Okay. So generally, irregular variations are can be done if there are any natural calamities. Secular variation, it has happened for every 250 years. Generally, 5 degrees to 5 seconds to 10 seconds per year. So these are the things, binaural variations. And what is isogonic lines? You need to know it. Isogonic lines. Isogonic lines. Isogonic lines is the line joining the points of same declination. Point of same declination. So those lines are called isogonic lines. Agonic lines. So what is agonic line? It is the line joining the points of zero declination. Line joining the point of zero declination. That means when magnetic bearing, magnetic meridian and true meridian coincides, then we have zero declination. So the points joining, the line joining those points, zero declination points are called agonic lines. Okay. So sometimes you need to note this in problems for to trick you. They will ask, they just don't mention the true bearing, and they just mention like true bearing of sun at noon. So at that case, how much value you will take? What is the true bearing value you take? True bearing of sun at noon is 180 degrees, right? And next, if true bearing, I already told you, true bearing is also known as azimuth. True bearing is also known as azimuth. They don't mention like true bearing, and they just mention in the question like true bearing, azimuth. Then you need to consider it as true bearing. Okay. If longitude is greater than the standard meridian, then the difference between them will be added to the standard time to get the mean local time. If my longitude is greater than the standard meridian, then the difference will be added to the standard time to get the local mean time. Okay. Next, one important topic is local attraction. Local attraction. So what is this local attraction? This is an error. Okay. So this is the deviation of magnetic needle with influence of magnetic attracted materials like fences, steel materials. Surround if they are surrounded with them, the magnetic needle will fluctuate. Then there will be an error in your calculation. That is called local attraction. So how do we detect this local attraction? Like how do we detect when error is there? If my difference of forebearing and back bearing is not equal to 180 degrees, then there will be local attraction. Okay. Um, so what is the correction for local attraction? They will ask correction for local attraction. So what do we do for corrections? We will check what are the forebearings and back bearings of that points, different points given. And if my forebearing minus back bearing is not equal to 180, then there are correction. Then there will be corrections, right? Then if my forebearing minus back bearing is equal to 180, then there is zero correction. If it differs, then the value differed will be your local attraction. So, like, okay, let's see line, forebearing, back bearing, and the correction. Line AB, BC, CD, DA. 120 degrees, 30 minutes, 299 minutes, 140 degrees, 30 minutes, 320 degrees, 30 minutes, 80 degrees, 261 degrees, 100 degrees, 30 minutes, 281 degrees. Okay. So as you can see, you just draw the traverse AB, BC, CD, DA. So AB, BC, CD, and DA. Okay. So this is your forebearing. Forebearing 120 and back bearing is right. So this AB and BC, what is the angle? So this is your if we'll just do the forebearing back bearing minus forebearing or forebearing minus back bearing, then we will check. So let's check like back bearing of back bearing of BC minus forebearing of BC. So back bearing of BC and forebearing of BC. If you check, it is like 180 degrees. That means B and C are free from corrections. Points B and C are free from corrections. And if we go with the forebearing of CD and forebearing of DA, then there will be 1 degree correction. So minus 1 degree correction at D and minus 1 degree 30 minutes correction at A. You need to draw the traverse and you need to check the forebearings and back bearings. Forebearing minus back bearing minus forebearing must be equal to 180. Then there is no local correction and it is error free. If there are any errors, we need to add it if it is more than 180 or less than 180. So these are angular measurements. So let's take few questions from previous grade papers. Yeah. So let's take one question. The magnetic declination at a place if magnetic bearing of the sun at noon is 184 degrees. So they are asking magnetic declination if the magnetic bearing of sun at noon is, if magnetic bearing of sun at noon is 184 degrees. They're asking declination. So what is declination? It is nothing but magnetic bearing minus true bearing, right? So what is your magnetic bearing? Or true bearing minus magnetic bearing, it is like plus or minus, you make it. So it is given 184 degrees true bearing. And what is magnetic bearing? Magnetic bearing is 184 degrees. What is the true bearing of sun at noon? What is the true bearing of sun at noon? It is nothing but joining the Earth's magnetic north and south at noon. It is like 180 degrees. I have told you earlier. So 184 minus 180 degrees. Then my declination, magnetic declination is 4 degrees west. Got it? And they will ask you like this. If they will give bearings and they will ask internal angles. Okay. I will solve one problem. They are giving the bearing of AB. Bearing of AB is equal to 50 degrees. Bearing of BC is equal to 310 degrees. Then ABC, angle B, they are asking. So how do we calculate? So generally angle ABC, B angle is nothing but back bearing of AB minus forebearing of BC, right? So it is given bearing of AB is 50, forebearing is given 50. So what will be the back bearing? Back bearing of AB is nothing but 180 plus 50, right? And the forebearing of BC is 310 they have given. So back bearing of AB is 180 plus 50 minus forebearing of BC 310. So that is 80 degrees. 80 degrees is my angle B. Okay, you need to do like this. So till now, till now we have just dealt with, from the topics of your consideration, we have dealt principles of surveying. Just wait. I'll go with the first page. So till now we have dealt principles of surveying, right? And errors and their adjustment. What are the errors and their adjustments? Maps, scales, coordinate systems, distance and angle measurement. Okay, so till these topics we have covered. Now we need to discuss with leveling and trigonometric leveling. So what is leveling and what do we do in leveling? So it is nothing but measurements in vertical planes. So leveling is nothing but the measurement of vertical planes or elevations or the difference of elevations between 2 points is nothing but leveling. Just give me a second. So leveling. What is the principle of leveling? Is nothing but measurements in vertical plane. Measurements in vertical plane. So what are the objectives? What are the objectives of leveling? It is nothing but to find reduced level RL, to find RL of different objects lying on, above or below the earth. Different objects lying on or above or below the earth, below the earth's surface. So to find the reduced level of different objects lying on or above or below the earth's surface, means lying on or above or below the earth's surface, we used to find the reduced level of that objects. Okay, and to establish points at a given elevation with respect to datum. To establish points given with respect to datum. Okay, so next, what are the uses of leveling? So with the leveled data, what we can do? We can prepare contour maps. We have dealt in the last class. What is contour? Contour is nothing but the line joining the points of equal elevation. Okay, so we can prepare with different leveling, different, we just know the different points of different elevation. If we join the points of equal elevation, we can prepare the altitude contour map. Next, altitudes of different points. Altitudes of different points. For suppose altitude is nothing but height in general word. So hill, I want to know the height of this hill, altitude of this hill. I can do this with help of leveling. And next, to prepare layout of water distribution system, drainage system. To prepare layouts for water distribution, drainages, etc. And to prepare longitudinal sections and cross sections of a project, right? So, and to know the cross sections of the project, we need longitudinal and cross sections of projects. So, these are the uses of leveling. So, till now we have dealt with the principle, objectives, and uses of leveling, right? So, what are the terms used in leveling generally? So, what are the terms used in leveling? Yes, please. The terms used in leveling is nothing but one, level surface, level line, horizontal plane, vertical plane, datum, mean sea level, benchmark, reduced level, right? So this is your datum or mean sea level. This is level line 1 and level line 2. So the difference in this levels, okay, there is a difference in this levels. What is level surface? Curved surface perpendicular to the direction of gravity is nothing but level surface. What is horizontal plane? The tangent to the level surface and perpendicular to the plumb bob is nothing but this horizontal plane, tangent to the level surface. Vertical plane, it is normal to the horizontal plane and it is shown by plumb bob. Datum, any surface to which the elevations are referred is considered as datum. Mean sea level, the average height of the sea for all the stages of tides considered for 19 years. Mean sea level is nothing but average height of sea considering all stages of stages of tides for 19 years. Okay, that is mean sea level. What is benchmark? It is a permanent point of reference whose elevations with respect to datum is nothing but benchmark. They are benchmarks like they're permanent benchmarks, temporary benchmarks, arbitrary benchmarks. Okay. So what is reduced level? The elevation of a point above or below datum is nothing but reduced level. You need to note it. Reduced level. Elevation of a point above or below datum. Elevation of a point above or below datum is nothing but reduced level. Okay. So methods of leveling. There are different methods of leveling. Just give me a sec. So methods of leveling. So different methods of leveling: barometric leveling, indirect leveling, or trigonometric trigonometrical leveling, spirit leveling, or direct leveling. Spirit or direct leveling. These are the methods of leveling. Okay. What is barometric leveling? So this in the barometric leveling, reduced level is nothing but the pressure difference between two barometric points is nothing but pressure difference between two barometric points, or the points measured with help of barometer. Okay. Next, indirect or trigonometric leveling. Okay, the heights and distance of various points are calculated by taking the vertical angles. If we consider vertical angles, heights and distances of various points can be calculated by taking the vertical points in case of indirect or trigonometric leveling. Next, spirit or direct leveling. The concept of telescope and spirit level is coupled here. Concept of telescope and spirit level is coupled. So what are the instruments used in leveling? Come on, anyone? What are the instruments used in leveling? So leveling instruments are dumpy level, auto level, and we use one leveling strap, right? Self-reading leveling strap, target leveling strap, and it consists of the level consists of telescope, leveling head, level tube, and tripod, right? So what are the defects we can encounter here? Telescopic defects. So that means optimal defects we can encounter in this case. Optical defects, magnification defects. So there are two types of magnification of a telescope is inversely proportional to the illuminance of lens. Illumination of lens. So what is illumination? Illumination means the proper light requirement. That illumination depends upon the generally quality of lens and magnification factor and powers of lens and number of lenses used also. Okay, it depends upon quality of lens, magnification power of lens, and number of lenses used. So there are two types of telescopes: external focusing telescopes also two types: external focusing telescopes, internal focusing telescopes. External focusing means it is the one which focusing is done by the external movement of either object or eyepiece. Okay. Internal focusing telescope means the focusing is done internally by negative lens. Focus is done internally by negative lens. So next, what is leveling staff? So you can see it like leveling staff. High batch and leveling control. Okay. Generally, we prefer internal focusing telescope. It is more advantageous than external focusing telescope. So there won't be any errors if we do the external focusing now, but with respect to the external objects, there may be some errors because of this illuminations and magnification factors. The next topic is types of leveling. Next topic is types of leveling. Types of leveling. So what are the different types of leveling? Differential leveling, differential leveling, or fly leveling, or check leveling, or check leveling. Next is profile leveling, profile leveling, longitudinal, longitudinal sectioning, and cross sectioning, precise leveling, and reciprocal leveling. So these are all the types of levelings. Okay. We will deal with the terms and the types of levelings in the next session. Thank you for your patient listening.